Hello everyone. Now welcome to this second tutorials in this course DGM, Deep Generative Models. In today's course, now we will be looking into the basics of PyTorch. Uh, the whole of the course, you will be learning a lot of theory, how the how can you mathematically formulate a model, and then in addition to that, you'll be learning how you can implement these kind of models on some simple data sets. Okay. We will be using Google Colab for this specific exercise. Now, Google Colab is a platform which gives us access to a simple GPU, 12 gig GPU. Now, we can use it. Now, the whole coding exercise throughout the whole course is structured in such a way that we will not be needing more than that. We will be implementing a very simpler versions of those models, and then we'll be discussing how to extend those models if you have compute resource. So in the previous tutorials that we have undergone, we looked at the idea of forward propagation and backward propagation, and how does your gradients are computed, and then we looked at the overall training procedure. Okay. Now in this specific tutorial, we'll be looking at PyTorch basic. Now we will be using PyTorch. In addition to that, if someone is interested, they can look out for resources on how to implement similar models using TensorFlow. But the overall discussion is centered around PyTorch. Now, what do I assume as prerequisites for this specific tutorial? See, I'm assuming that you know the basic structure of MLP, and then you know the basic idea of CNNs. So basic structure of MLP, now we actually discussed in previous tutorial. Now, if you are not very much comfortable with the structure of CNNs, or you want to have a revision of the CNN structure, you can look at one resource, that is Stanford University CS 231 course. You can look at this resource. So here you can go to some useful notes in which they have curated a very interesting notes, and then you can look at the overall neural networks. They have explained each and every idea using a very nice examples, as well as a detailed notes has been provided. Now, if you are not so much comfortable with CNNs, you can go to CNN notes, and then here they have given a detailed overview of the convolutional layers. How do they work? Now, what do you mean by the idea of parameter sharing? Now, what are features? Now, given an input, how do you calculate? Now, this is how the operation of convolution happens. Now, what are the essential parameters that are there has been described in detail in this resource. Now you can look at this resource. Now CS231N, Stanford course on computer vision. They have elaborately given a very nice, they have curated a very nice notes. You can look at these notes, then look at the idea of convolutions and the idea of neural networks altogether. I'm assuming that these prerequisites are known, then we have given the reference material. Okay. So now coming back to PyTorch, we will be using the standard PyTorch tutorial available in public. We will be just going through that and then explaining you where much more elaboration is needed. And then we'll be running those codes whenever needed. And then at the fag end of this specific tutorial, what we shall be doing is we shall be writing a simple structure to read some of the data sets that are there and work on those data sets. Okay, that is the overall idea. without any further delay, so let's start into it. Now, how do you get to this page? Is just in your browser of your choice, just type PyTorch tutorial. Now, you will be going to, this is the official PyTorch tutorials, or you can go to this link, pytorch.org tutorials /index.html. You can go to this. This is the basic tutorials. It has tutorials on most of these ideas, but we'll be going ahead with a very simple basics. We'll be looking at only these basics, and then the extensions of it, you can actually look at it, and it has on all these ideas. So now let's start with quick start. Okay. Now, what it has done is they have given for each of these tutorials, they have given either you can run it on Collab or you can download the notebook and then you can use your own local machine or the Visual Studio or the Jupyter notebook that you have, you can use it, or you can look at GitHub. But what I shall be doing in this tutorial is we'll be running on the Collab so that you are much comfortable with the Collab environment as well, and then you are comfortable with the idea of tensor, so the idea of PyTorch as well. Okay, yeah. So this is kind of summary of everything. So we don't no need to go there. Now let's go to tensors. Okay, I'll be opening it in the Collab. Okay. So this will open a Collab thing, Collab notebook. Okay, so the Collab notebook that is there will have these kinds of dialog boxes. Now this is having the extension IPYNB, which means Interactive Python Notebook. Okay, this is the name of the file. So where this, so whenever you are running any instruction or running a code, now it has to physically run on some device, right? Now where is the device? Now the device is not present in this is not using your local resources. Now what is happening is in the Google server, now it has given you a chunk of a resource, and then you will be running your code in that specific chunk. Okay, so now this removes all the problem of installing the packages, maintaining those necessary packages, and all those hassles have been removed. Now we will not be worrying about any of them. So we shall be directly going ahead and learning now what is necessary. And then what I assume is you know Python. Okay, now that is the assumption. Now, if you are not so much comfortable with Python, now I urge you to go ahead and look at simple course on Python, in which so you can learn the basics of Python. So now, what are tensors? Now, tensors are the building blocks of this overall PyTorch. Okay. Now you can think of them as some kind of a specialized structure. Okay. Now, which are very similar to the arrays or the matrices that we have. Now, if you have worked with NumPy, now it has something called as ND array, so n-dimensional array. Now, this is similar to that, but what happens is now this tensor which is there, now it can run on GPU and other hardware accelerators. So now GPUs are the one which gave a huge push to the deep learning. Okay, so you can run these tensors or the operations on these tensors on the GPU. Okay, that is the added advantage of these using these libraries, PyTorch, which has a simple data structure called as a tensor. Now, in this first notebook that we have, so now let's look at how do you create a tensor, okay, and how do you do some of the basic operations on these tensors. Okay. Now, to do so, the first couple of libraries that are needed, now whenever you are working on PyTorch, the first library that is needed is Torch. Now, therefore, you import Torch. Okay, and then so you need data. Now, either you can create a list and convert it into a tensor, or you create a NumPy array and then convert it into a tensor. Now, for a list, you don't need to import any libraries. Now, if you are going ahead and putting it as a NumPy array, now at that time you will be needing a NumPy. So you need to import it. Now let me run it. Now this is how you run it. You just click on the play button. Now whenever you are running it for the first time, Now it will take some time now because it has to establish a connection with the server. So it will take some time to run. Okay. Now these text blocks. Now this is text block and this is code block. Now we don't. So in the text block, more information will be given. Now code block is where you write your code snippets and run. Okay. Now I assume that you are pretty much comfortable with all these basic ideas. Okay. Yeah. So now you create a data. You create a two-dimensional array. This is a two-dimensional array, or it is famously called as a matrix. Okay. This is a two-dimensional array or a list. Okay. So now what you are trying to do is, now you are trying to convert this list or a two-dimensional array that you have into a tensor. Now, how do you do it? Now you just use the method tensor torch.tensor. You use this torch.tensor. Now to that method, you pass this data as an argument. Now that will return a tensor type data now with the same values in it. Okay. Now the values will not be modified, only the kind of data. Now this will be a list. This data will be a list. Now you can check it by using type of data. You can check it. Now this will be a list. Now you are changing the type of this. Let's run this. And this is how if you have a list, if your data is a list, you can convert it into a tensor. Now on the other way, if you have your data as a NumPy array, okay. Now, so in the first line here, I'm converting my data, which is a list, into NumPy array. So now I have a NumPy array. Now, how do you convert your NumPy array into a tensor? Okay. So now you use this NumPy array torch. You use a method torch.from NumPy. Okay. You pass this converted NumPy array. Now you get this tensor, which has been created using NumPy array. So now this means that you can create a tensor now using a list under your thing, or you can do it using a NumPy array under your data. Okay. So now most of the times, now what will happen is now we need to create a random tensor, okay, or a tensor with some specific values, like I want all the values as 1, or I want a random tensor now of specific size. Okay. Now we have two ways of creating that. Okay. Now one is you directly give the data now which is of that size. Okay. Or you say that, okay, I want of this size. If you give the data itself, now internally what it will do is it will calculate the size, and then it will create a new pseudo data or a dummy data of that specific size. If not, if you give the size itself, it will directly do it. Okay. Now let's look at both of these ways. Now you have this X data. Now I want a tensor in which all the values are 1. Now what is this X data? X data is a tensor. So it's a 2D tensor. Okay. I want a tensor. I want a 2D tensor again. Now in which all the values are 1. All the values are 1. Now if this data now which is there has some other properties, even those properties now will be transferred to X, the new X1s now that is being created. Okay. Now this is in which all the values are 1s. Now in addition to that, now if you want okay, now if you want random values, so now then what will happen is you just pass this data, and then you're saying that the data type of this should be float. Now, but you can see that the data type here is integer. Now, what it will do is it will override this X data, now which is override the type of this X data, and then now you will have a 2D tensor now in which all the value will be a floating point values. We can print them. You can see that all are 1s. You can see the size of it. It is a 2x2 tensor. Similarly, if I run it again, you can see that different values are getting generated because you are doing a sampling your random thing. This is how, if you pass the data similar to that structure, you can obtain the tensors. Now, in contrary to that, If you have the shape of the tensor, now what I'll do is, now what they have done, now what I'll know, it's not me who has curated this. This is the standard things that we are using. Now they are saying that, okay, now the shape of the tensor should be a 2 cross 3. Okay. So now so torch.rand. Now if you use this method and pass the shape, now it will create a random tensor now of size 2 cross 3. Okay. Now if you want all ones, now then you can use torch.ones, where in which you just pass the shape to this method, and then you create a tensor where in which all the ones are there, and then torch.0. So you pass the shape to this method, now where in which all the values will be 0. Okay. You can see this here. A 2 cross 3 tensor is being created here. Now this is a random tensor. The first one is a random tensor. The second one is a tensor in which all the ones are there. The third one is a tensor in which all the values are zeros. Okay. So now that means that you can create tensors using, if you want a structure, if you want a shape, specific shape, either you can relate it to the data that you have and then get it, or you can specify the shape and then you can get it. Okay. So now then look at some of the attributes of tensors. Okay. So now one is the shape of the tensor. Another is what is the type of each of those values that are there, and on what device is it running. Okay. See, what happens is, now whenever in your system, if you have a GPU, now CPU has to be present for sure. Now your tensor can be on the CPU or on the GPU. Okay. Now, depending on that, now I can say that, okay, on what device it is. Is it on CPU or is it on GPU? Now, let's run this and see. Now, the shape of the tensor is 3 cross 4. As we can see that it is generated this block. And then you can say that, okay, this is the shape and this is the type, data type of it. D type is data type. Now it is saying that it has float 32. And then the device on which these values are present are CPUs. I'm not still using my GPU. Okay. Now these are some of the attributes that are there for tensor. Okay. So now let's try to look at how do you actually move your tensor into an accelerator if it is available. Now we will come back to this. Now let's not do it now. This is slicing and indexing. Now we will not be needing this slicing and indexing during our course, so I will not be spending much time on this slicing and indexing. If you know the slicing and indexing of NumPy, now it is exactly similar to the slicing and indexing. Okay. Now you can look at it. Okay. Yeah. So here, the first one, we can look at it. Now you're creating a torch, you're creating a tensor in which all the values are ones. The shape of that is 4 cross 4. And then you're doing some kind of slicing and indexing ideas that you're trying to do. Okay. So I shall not be going into that. Now, how do you concatenate tensors? Okay. Now you have a tensor. Now that means it's a matrix. Now how do you concatenate a matrix? Now when I say how do you concatenate a matrix, the question is, now do I need to put one next to another or one below another? Okay. Now this will be the standard question that is there, now which needs to be answered now whenever we say that, okay, now go ahead and take a tensor and concatenate it. Okay. So now let's look at this thing and then let's see how it is there. Now torch.cat, now that is the method that is used to concatenate, now when which you provide a list of tensors. Now here, all of them is the same tensor. And then you have something called as dimension 1. Now, what is this dimension 1? And then you are printing this. Okay, let's see now how it happens. Now, each tensor is a 4 cross 4 matrix. Now, that is known to us. Let's look at this. Now, what happened here? Now, you see 1, 2, 3. Okay, maybe I did not run it. So, I still have a, sorry, I still have a 2 cross 3. Okay. Now, let me run it. Yeah. Okay. Now, this is the tensor that I have. Now it has 1, 2, 3, 4. Okay. Now it has 4 rows, and then how many columns are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now has to be, yes, yeah. So it has repeated thrice. Okay. Now 4 cross 4. Next to that 4 cross 4. Next to that 4 cross 4. So now you have 12 columns and then you have 4 rows. Now that means that dimension 1. Now what does it mean is now you are concatenating as columns. Now if you want to concatenate as rows, now you just change this dimension to 0. And if you run it, now you can see that it has been concatenated as rows. So now, whenever you want to do concatenation, the question that arises is, no, do you want to concatenate it as columns or do you want to concatenate with rows? Now, those things can be handled with changing the dimension of it. Okay. So now, yeah, this is one operation that we need. The next operation that is needed is the idea of matrix multiplication, which is the seminal idea in most of the neural networks. For all practical purposes, your whole forward propagation in a neural network can be thought as a matrix multiplication, actually. Okay. So now, how do you perform matrix multiplication is the question here. Okay. I assume that you know the basic rules of matrix multiplication. Now, what are the kinds of things? Okay, let me tell you that rules again. Okay. Now, if you have a matrix, A, which is of size m cross n, and then you have a matrix B, which is of size n cross p. Then you can multiply this matrix. Okay. And then you get a matrix C, which is m cross p. Okay. So now these two things should match. Okay. The columns of the first matrix has the number of columns in the first matrix has to match with number of rows in the second matrix. Now then you can perform this matrix multiplication. Okay. That is a standard rule that is used. Okay. So now you are taking a tensor now which is of size 4 cross 4. Okay. So and then you want to multiply. Now multiply it with what? Okay. Now you have one matrix which is 4 cross 4 that you want to multiply. Now what are the options? Now you have to have 4 cross anything. Okay, then you can multiply. So now the tensor, now which is a 4 cross 4 matrix, that is being multiplied with tensor dot t. Now what is this t? Now dot t is used to take the transpose operation. Okay. That is the transpose operation. Okay. And this at symbol which is there is used for matrix multiplication. Tensor, now it is a 4 cross 4 matrix into tensor, the transpose of it. Okay. Now tensor is a 4 cross 4 matrix. So the transpose of which will also be a 4 cross 4 matrix. Now you are multiplying a 4 cross 4 matrix with another 4 cross 4 matrix. The outcome will be a 4 cross 4 matrix. Okay. Now you can use at. Now this is matrix 1 and this is matrix 2. So you can multiply it. This is one method of doing it. Okay. Now then you have another method. Now you can use the first matrix dot. You can call a method from there, from this tensor, which is matmul, matrix multiplication, which is this form as matmul, and then you pass the argument the second matrix. Okay. So now this is same as multiplying the first matrix with the second matrix. Now this is one more way of performing the matrix multiplication. The third way of performing matrix multiplication is directly using the library torch. Now it has a method called as matmul. Now in which you have to pass both the matrix A and B. And not only that, in addition to that, you should even pass the resultant matrix. Okay. So now that's the reason why you create a resultant matrix, just the structure of it, torch.rand like all the random values of y1. Y1 is this matrix. Okay, that is y3, and then you are passing it. Now you multiply this tensor and with its transpose, and the output will be stored in this y3. Okay. Now these are the three ways in which you can multiply matrices. Now one is using the at. Another is using first matrix dot matmul, or you can use the torch dot matmul, when which will be passing both the matrices as well as where do you want to store the resultant as the input. Okay. Now this is matrix multiplication. Now the one more important thing that so we shall be needing is the idea of element-wise multiplication. So now what is this element-wise multiplication? Just take a look at it. Okay. Now, let's look at this. Now, element-wise multiplication is one of the core operations involved in convolutions. Okay. Element-wise. Now, to perform element-wise multiplication, now A and B should be of same size. Okay. A and B should be of same size. Okay. Now let's take a matrix A. Let me put some random values. I'll just take a simple 2 cross 2 matrix. 1, 2, minus 2, 3. This is one matrix. And the second matrix B, which should be of the same size again, 2 cross 2. I'll take 4, 2, 1, 3. Okay. Let me not put 3. Let me put minus 1. Now, how do you perform this element-wise multiplication? Now, that is C equals, it will be 1 into 4, 2 into 2, minus 2 into 1, 3 into minus 5. Okay. You take each and every element and then you perform the multiplication. Take this element, multiply with this. Take this. Okay. And then you will be able to get the resultant of this. Okay. This is the idea of element-wise multiplication. Okay. So now, how do you do this element-wise multiplication? You you have a tensor now, which is of size 4 cross 4 that we have already created. Now, into tensor, you use this star symbol here. Okay, this is one. Or you can use tensor.mul, not matmul. Matmul is matrix multiplication. So I presume that now you are pretty much clear with the idea of matrix multiplication and how is it different from element-wise multiplication. Okay, or element-wise product as it is called as. Okay. Now the first matrix dot mul, now you call the method there. So and then you pass the second matrix as an argument. Or as we saw earlier, now you pass both of them, torch.mul, you pass both of them, and even you pass the resultant. Okay. Now these are some of the basic operations that you perform on the tenses. Okay. Let me run it. Yeah. You can look at it comfortably. Okay. So now with this, I assume that you know the basics of tensors, what are the attributes of the tensors, and how do you create a random tensor, a tensor with all ones, and how do you perform the very basic operations of product, element-wise product, and the matrix multiplication. Now, similarly, you can do addition, subtraction, and other things. And those are trivial tasks. That's the reason why they haven't elaborated on that. Okay. So now that completes the first idea, which is the tensors.